Hey there. Today we are talking about linearization. We're in section 5.5. You will learn how to find the linear approximation for a point A to estimate values close to A. So in a linearization, you have function f. It's differentiable at x equals A. Then the equation of the tangent line is equal to this. So L of x, standing for linearization, is equal to f of a, so your y value, plus the derivative at a, so the slope at a, times x minus a. This should look very similar, very familiar to you. It should look like kind of like a slope intercept. Like if you moved f of a to the other side, it should look like slope intercept, or excuse me, point slope form. It defines a linearization. The approximation f of x is equivalent to L of x. It's a standard linear approximation of f at a, and a is considered the center of approximation. I don't do a whole lot with the center, but I do talk about it. So first thing we are going to do is find a linearization of cosine of x at x equals pi over 2 and use it to approximate cosine of 1.75 without a calculator. So how we're going to do this is we need to do a couple things. We need to find f of pi over 2, and cosine of pi over 2 is 0. It's at the top of the unit circle. We also need to find the derivative, which we get negative sine of x. And we need to evaluate the derivative, at pi over 2. So at the top of the unit circle, we get positive 1, but because the sign is negative, this should be a negative 1. So I'm going to start by writing my linearization, and it equals f of a plus my slope, f prime of a, times x minus a. Just simply because I have a negative 1 here and I have a 0 there, I'm going to simplify this. So I end up with negative x plus pi over 2. We are using that to approximate cosine of 1.75. So if I put 1.75 into my equation, and we're not using a calculator, just leave it. Here's my answer, okay? So let's talk about, I'm going to go back to the Smart Notebook. Let's talk about, so here is my cosine function. Here is the linear approximation at pi over 2. And is my estimate above or below the line? Well, it should be what? Above the line or below the line? So pi over 2, is that above 1.75 or below 1.75? So we need to think about that. And here, if it lands up here, it'll be below my line, so less than. And here it'll be above the line, so greater than. So I want you to decide that. Is it above or below? Next, we are let f be a function with my derivative. I gave you the derivative, and I gave you the value. We are find the linearization of f at x equals 0. So what we are doing now, there we go. So here is my derivative. There is my point. We're finding the linearization. So the first thing that I need to do, I need to find f prime of 0, which is 1. And I'm setting it up my linearization. So I have 5 plus 1 times x minus 0. So if I simplify this, which I do like to simplify these because it does make our life a lot easier, I get x plus 5. Woohoo! All right, so our linear approximation at point 1, I get 0.1 plus 5, which is 5.1. So I have this here, I have this here. And is the actual value greater than or less than the approximation? So I want you to think about, if you were to put this into your original, okay, would this value here be greater than or less than the original value? So is the tangent line above or below the equation at that point? Again, I want you to think about that. Last thing is just a review problem. I just want to see if you can do this. So container in the shape of a right circular cylinder with no top has a surface area of 3 pi feet squared. The height and the base will maximize, what height and base will maximize the volume? So think about that. Come to class, give me an answer. Thanks.